Okay, thank you, Daniel. As Daniel said, I'm Sebastian Damm, working for Sipgate as a voice over IP engineer, and together with my team, I'm handling most of the telephony stuff in the Sipgate network. And today I'm gonna present how we did our interconnection, our NGN interconnection with Deutsche Telekom using just open source software. Why I chose this topic was because, Telecom wants to abandon all the PSTN and ISDN accesses, and although I think the carrier interconnects will stay a bit longer, but over the next years, all carriers that have interconnection with Telecom will be forced to migrate to NGN. As I said, I'm working for Sipgate, and we are a voice over IP service provider, started in 2004, offering first only private customer products, then later added a hosted PBX solution to serve business customers as well. In 2012, we became a full MVNO in the E+ network, now Telefonica, and so that gave us the opportunity to offer pretty flexible solutions to our customers. And you all heard the Telenor talk this morning, and I was a bit smiling because I thought we were the only ones doing everything in-house and doing everything open source and or at least trying to do it. But that Telenor way did look a bit like the Sipgate way, pun intended. Okay, let's start. This is the basic setup overview of how it looks, of how our interconnect looks like. On the left side, you see the telecom part, and the only interesting thing about that is that we have 3 session border controllers on their side that we are talking to. And then we have 2 direct interconnects between them and us, and direct interconnect means that you have to find a data center where you and your telecom is located. Then on our side, Telecom provided us with 2/28 networks where we could set up our stuff, and we set up independently in 2 data centers the same equipment, so we could use either one of it and have redundancy. The detailed setup on our side looks like this, and you can see there's it starts with a load balancer. We took Kamailio for it, of course, and actually the main modules that we are using in Kamailio are the dispatcher module for sending calls on to either side, and the RTP engine module to select the RTP proxy. As you can see, the load balancers are connected to either SBC and to all of the RTP engines, because Telecom doesn't care what's happening after the load balancer, because that's the only thing they see in the signaling. As an SBC, in our case, we took Yate for it, but you can easily replace it by any back-to-back user agent you like. But that's the main logic unit in our setup, and what we do there is just handling phone numbers or formatting the packets correctly, and looking up carrier information and looking up some Sipgate customer information there, and then sending on the packets. I'm gonna run through some call flows really quick, and that's the simplest one. It's just coming in on one side, like the top one is the Düsseldorf side, and going through the load balancer SBC there, and then going to the Sipgate world, but it easily could look like this, where it just ends up on the other SBC. Telecom doesn't care about where the RTP is going through, so we can have signaling on in one data center, but can have the RTP going through the other one. And in the case of an outage, Telecom just sends us the traffic through the other interconnect, but still can reach our site where the direct interconnect has an outage. For detecting that, we are using BFD right now, but Telecom offers link loss forwarding as well, I think, but that didn't work for our setup. And the outbound call comes from Sipgate directly to the SPC, and then the SPC sends it on to the load balancer, and the load balancer again uses the dispatcher module to select the SPC where on the Telecom side where it wants to send the call to. That's basically it for the setup, but I wouldn't be here if it was that easy. There are some specialties. The first thing that you will notice when doing some interconnection testing is that in a lot of times you're actually testing the SIP devices behind it. There are some features like call hold or three-way conferences that were net features in the old telephony networks, but in the NDN networks, those net devices don't care about it, and they let the end devices handle those call hold things. So you should use some devices that are pretty close to all the standards. And in our case, we used SNOM, and Telecom used SNOM as well, and there was only one error in the firmware when doing double hold scenario and then getting the call back, and but that was just a note that ended up in the results, but nothing major. And you have to be prepared to go through billing hell, and that's really. We got a 120-page PDF from Telecom telling us all different kind of rates for all different kind of call scenarios, and you have to implement them on all on your side. And that took us quite a while. At the end, we came up with like a 750 lines long YAML file for configuring our billing system, but we passed it. And what I heard from our Telecom contact person, that's the part where a lot of carriers get stuck, and then the testing won't go any further. And you have to expect some signaling specialties. The first one is, from time to time, there are some interesting request URIs. Anybody ever seen this kind of URI? Okay, some, but few. There are 3 parts in the user part of the URI, and what this URI just tells you is that there's been some number porting taken place, and that's what this part tells you, and there's the carrier code where the numbers has been ported, and that's what the request URI tells you. And if you want to extract this information, then you have to be able to deal with those kind of URIs. Call direction, yeah, that's pretty big part of of testing. So you have to take incoming calls, direct send them back to Telecom, and send them, and then they send them back to you, and all that stuff. And we're using diversion, right? Who's using diversion for indicating redirection?
NS7 too.
NS7.
Yeah,
Yeah, but I thought actually before the test that diversion was the only part, the only way to indicate redirection information, but it won't work. Who knows that that actually diversion, or who has read the standard lately? It starts with, this is for archive purposes only, and diversion never made it into a standard. Actually, there's another one. It's called history info. And of course, this one is the actual standard for indicating redirection. But the fun part is, I found no open source project actually supporting it. I looked through Kamailio, asterisk, Matt? I found a variable in FreeSwitch where you can at least read it, but nothing to convert from diversion to history info. But that's how it has to look like. We got a call in, and then we wanted to send it back out, and so we put the you have to put the B number, the originally called number, in there, and then at the target number of the redirection, you have to put the cause in there. You even can specify whether the redirection information has to should be shown or not, and that's what Telecom wants to see. And if they do another redirection, then they just add another entry to this header and increment the index. Incrementing means adding a .1 at the end. Really fun. There's an RFC actually, like 6044 or something like that, that tells you how to convert between diversion and history info and vice versa. Another funny header is the P Germany tariff header. Yeah, it's never seen that before, and probably never see it again. But then if you're offering inbound calls to service number or premium rate numbers, then there's some more information that they are going to give you. And so it could be that an incoming call to a service number has a German caller ID, but actually was received by Telecom from an international interconnect. And I said they have a tariff for everything. They have a tariff for this situation as well. And they, because they don't want to pay you anything in this case. And then they had a P Germany tariff header with the content of tariff equals 99. And you have to be prepared to use that information and enrich your CDRs so you can bill the call correctly, and otherwise Telecom will reject the bill. And the other thing is, if you are offering premium rate numbers, then they are defining the tariff class, so you know how much money your customer will get from this inbound call. If you want to offer telephony services, then you probably have to offer emergency calls as well. And there are call center addresses in Germany when you are sending out emergency calls. And in ISAP, you would only send the call center address, and that's it. In SIP, you have to mangle some numbers. You have to first cut out the CC from the target number, and then put another part in the user part and add it again. And that's one thing that already existed in the SS7 network, but in the NGN network, it's mandatory. You have to add user-to-user information, which, and as we all can read, that's our office location in Düsseldorf. That's what's coded in there. Actually, yeah, we did it. Our lab test took us 2 weeks, and Telecom was really impressed of our speed, and we could adapt to all the slight changes that we had to make really quick. The live test, well, took a bit longer, but there were some IP issues, like the BFD wasn't enabled on the telecom network, and we had to negotiate that we want to use that. And later, the P Germany tariff header, apparently we were the first ones to actually test service numbers on NGN, and so it wasn't implemented on the telecom side. And from where we could do it or adapt to some errors pretty quick and come back the next day and say, okay, let's test that again. We waited for like 2 or 3 months for telecom to have that implemented in their systems. So be prepared that the live test is taking a bit longer. That's already it for the test, but there are 2 more things that we saw in when using NGN interconnects, and that I want to share with you real quick. There's a pretty simple equation. What that means is, those of you coming from Germany probably remember last year in December there was a big outage of the VoIP systems of telecom, and that was at the time when we were testing live traffic and sending a lot of calls to telecom NGN customers through our new interconnect. And suddenly they all came back with 404. And so what we were doing, or what our systems were doing, play an announcement, this number is unassigned. But actually 404 can mean the customer is offline and the number is unassigned. That's kind of a flaw in this standard. I mean, you could use 480 for an offline customer, but apparently no one uses it. And what that will bring up a lot of customer service calls, because customers don't know what they are doing wrong, and they will ask why this number is not reachable anymore. But and you have to go to the other carrier, and the other carrier will tell you that customer is just offline. And the other thing is codecs. In the old telephony network, there were no such things as different codecs, or but in SIP, you could easily configure the one device to only use G711A law and the other device to use G711U law. Like when you're calling from Europe to America, that could be a real life case. And what we saw is that a lot of providers don't do any transcoding at all. And that leaves the caller and the called party without a clue why the call won't go through. And what I really think is that providers have to learn that transcoding is sometimes necessary. And right now, we had this scenario before. We had a call we sent it to QSC, and this was an NGN customer at the QSC network, and the call came back with a 488. And so we had to call QSC, and they said, oh yeah, that's a codec problem with the end customer. What I think is that each provider should take care of the codecs and do some transcoding if necessary. Oh, yeah, one more thing. What about fax? Can we finally kill it? That's one good thing from the telecom NGN migration. I think we can. Telecom doesn't support no T38 at all. And so we transmitted like a 1 or 2 page test fax during the test, and that went through fine. But I hope there will be so many issues and problems when sending some 30-page contracts that fax will finally die. Those are some resources. There's the interconnect specs that's a working group came up with, and that the telecom interconnect is following, and emergency call specs and the redirection information. And if you want to chat, we have a really lovely office at at Düsseldorf, and if you're in the area, stop by. We have a great kitchen, not a virtual kitchen as Telenor, a real kitchen. And a fridge full of beer, Matt can tell you. And so stop by. Questions?
One of your beginning slides, you were saying that you were able to have the signaling go through one SBC, but RTP pass through a completely different data center.
Yeah.
How do you pull that off? The media is not passing through the 8, and how do you sync to tell one pop to the media?
Media is not passing through the SBC. It's the load balancer is putting in an address of the RTP proxy, and the SBC is just leaving the media alone.
Okay, so it's RTP proxy that you're using for the media, and signaling across interpop links to
RTP
say
engine,
relay.
Yeah.
Okay.
Okay. Back
my question is about the codecs as well. You are doing the transcoding on the RTP proxies, right?
No, actually not. We are doing transcoding, but we are doing it then on the Sipgate gateways. So the carrier where we did this interconnect test for is not handling any transcoding, but the Sipgate servers are.
But I assume you have many problems with license and buying licenses for many codecs. How many codecs are you able to transcode, and from which to which?
We are supporting G711A and U, and then G729, GSM, and we are buying licenses for G729.
Yeah, that's what I wanted to know. Thanks.
Hello, I have 2 questions. First, about transcoding. Have you looked at what percentage of calls you actually have to transcode?
Within Germany, it's probably not a lot of calls that we have to transcode, but I don't have any concrete numbers.
Okay, and the other question is, do you also do SMS? In the NGN network, no, we don't.
I have a question regarding the SIP setup. You were saying that you were putting a load balancer as let's say, the last node towards the NGN side, towards Deutsche Telekom. How does Deutsche Telekom react to that? I had the impression that they actually want to have a clear back-to-back usage and with only one route, one buyer and stuff like that. Is it not a problem for them?
They actually don't know. When we got the form to fill out what equipment we are using, we actually invented a name, and we are our own producer of our soft switch.
Okay, but from a signaling point of view, like from a SIP message, they don't complain if you have like route record routes.
No, the route headers are completely fine.
I've got a question regarding your billing. Are you doing it online via like OSP or Radius, or are you doing it postpaid with CDRs?
With Deutsche, in this carrier interconnection scenario, we're doing postpaid. And so we are just writing CDRs to a file and then parsing that file.
One, two? Yeah. What does Deutsche Telekom use? What kind of SBCs do they use on their side? Do you know? And why do they use 3 of them? What was the reason for that?
3 of them, that's just for load balancing on their side. And if there's an outage, then you still have 2 others. And what kind of SBCs? I think they are using IBM's systems.
Okay. Do they insist on any type of SBCs, or you just said that you named the SBC, so they don't care about that?
We just named it.
I'm asking because some years ago, 2 or 3 years ago, before that all stuff. I saw the list of SBCs, 4 or 5, Acme and things like this, Gen Band. So they don't insist anymore on the type of SBC.
No. And I think in the SS7 case, it was that if you use the well-known SBC on your side, then you could skip the lab test. But I think in the NGN interconnection, there's no skipping any tests anymore. You always have to do the lab test. And so it doesn't matter whether you're using some closed source box or using your own stuff.
So you can name it Acme with umlaut, Acme. Okay, Simon.
Am I allowed to ask a commercial question without getting lynched? That's one for Daniel more. Yeah. In a market I'm more familiar with, the only regulated means of interconnecting with the incumbent, i.e. to get regulated terms, is SS7. But they have an IP product. So we have this peculiar situation of effectively remonopolization because the regulator doesn't think SIP will catch on. Is that the same with DT? Do you have a regulated SIP interconnect to DT that's replaced the C7, or have your commercials completely changed?
Actually, I don't know.
Okay.
I only did the technical stuff, and I only got the 120-page PDF to where I had to grab all the billing information out of it, and where it came from, and whether we could do something about those numbers. I don't know.
Okay. All right. Thanks.
Okay. Two more.
Hi there. Could you tell me a little bit more about the testing setup before was it the 2 weeks testing setup? Was it in a closed network of some sort?
We actually got another /29 network from Telecom, and the first direct interconnect must or had to exist before. And so we set up like 3 virtual machines on our side and provided or used the IP addresses that we got.
Okay, so maybe the last question, and there are few guys from Sipgate, so grab them around here and ask them.
Yeah, I was just curious, how are you monitoring audio call quality, and also how does Deutsche Telekom react on faults on their side? Are they quick to solve them?
Depends probably on what kind of faults. If it's just an outage, then they probably react pretty quick. If they have something to implement, then they probably have to go to their supplier, and then it takes a while. And the monitoring of audio quality, we are using VoIP Future and have some probes just sniffing all the traffic, and then can look into the quality of each call.
Okay, thank you, Sebastian, again. The guys from Sipgate will be around.